Hi folks, it's chemistry time.
Yes, it's podcast 4.4.
Periodic trends.
All right.
And you're here with Miss Gray.
And Mrs. Zoe again.
Yes, aren't you lucky? All right, well we're going to talk about atoms and why they're organized the way they are.
Okay.
And why they behave the way they do. So we know what the nucleus is made of, right?
Yes.
Protons
And
neutrons.
Neutrons.
And what's the charge of a neutron?
It's neutral, so
So I'll leave it blank
yeah.
because it has no charge.
Yes.
The charge of the nucleus then, is it coming from the protons or the neutrons?
Comes from the protons.
Of course, because the neutrons don't have any charge to
Yes.
contribute. So the more protons we have, the higher the charge is.
charge.
And so we call this charge Z,
Or the
and that's what we mean by nuclear charge,
charge.
which is equal to the number of protons. Number of protons.
All right.
So if you want to know the charge of lithium, then you look at how many protons
How
it
many
has.
protons? Yeah.
Yeah. Now there's a little bit more to the story, but we're going to get into that.
Yes,
but that's our
exactly.
starting place anyway.
Mhm.
How many protons are there?
All right.
Okay. So then let's look at the electric force. The force of attraction between protons, and electrons. So I'm going to use F for force,
Okay.
and EL stands for electric
Electrons.
force. Right?
Electrostatic or
Right, electrostatic force, meaning
Okay.
that positive is attracted to negative.
okay.
And it's described by this equation that we use in physics. The charge of one particle
Okay. Physics.
times the charge of the second particle
Okay. Q1, Q2.
divided by the square of, I'm going to call this the distance. I put
Square
R
of the
for
distance,
radius.
D
The-
squared.
Yeah, the distance between them. And then this K is just a constant. We're not going to get to mess with that because it's constant.
Constant. Yes.
Always. Okay, but let's look at what happens when the charge of your particle increases.
Yes.
Okay, so I'm going to put in some numbers here. Let's say we have the electric force for hydrogen. Whoa, calm down. No pen. Electric force for hydrogen would be described by our K
Okay.
times one proton and one electron,
Yes.
right? Divided by whatever the
The
distance,
distance
is
is between them.
between them. Okay, so we're going to call this 1 times 1 is 1.
1.
Okay, now let's compare that to beryllium, since I'm looking at that in my chart behind the notes.
Okay.
All right, so look on the periodic table. What's the charge of, or how many protons are in beryllium?
Okay. So beryllium is
Luke and Andrew,
Number
you're needed
4?
in the front office.
number 4 is what is that?
That's the thing again.
It's 4.
Okay, beryllium is 4 protons then, and 4 electrons.
4 electrons.
They're negative, and divided by the square of the distance between the two charges. Okay, so what's 4 times negative 4?
Negative 16.
Wow, that
I'm
force went up by
Yeah.
a lot. Okay, so whoops, that's negative 2, right? Negative 1.
Yes. Yeah. Negative 1.
Right, and by negative forces we mean it's an attractive force. They pull towards one another.
Yes.
Right? Okay, so for hydrogen, we had a -1. Beryllium has only 4 protons, right? That's only 3 more than hydrogen.
Yes.
But it has a lot bigger
A
force.
lot. Yeah.
So imagine, in cars, we measure power or force by horsepower,
Yes.
right? So hydrogen pulls with 1 horse, beryllium gets to pull with 16 horses.
horses. Wow.
That's a big difference.
Yes.
Yeah. So electrostatic force is all governed by this Coulombs Law. When I mention physics in chemistry class, because they're all related.
Yeah, they are.
And
Yeah.
because matter has charges, we have to consider the forces between the charges.
Exactly.
So let's look at the electrons that are in the valence shell and how tightly an atom can hold on to them.
Okay. And we
Okay.
call them the electron affinity.
Right. And another term for it is electronegativity.
Yes.
And by that, we are talking about like how much it pulls on the electrons. More electronegativity pulls the
Pulls
electrons tighter
Tighter.
with more force. Okay? So which one can pull the electron with more force? We compared hydrogen to
And
beryllium.
beryllium.
So hydrogen was about 1, beryllium was about 16. I think the one with more horses can pull the electrons
Yes, and
closer.
that is beryllium.
Right, and beryllium indeed has a higher electronegativity than hydrogen.
Yes.
Okay. Let's look at the atomic radius.
All right.
And
Atomic
this,
radius.
again, is governed by Coulombs Law. You see, if you can pull the electrons harder, then you'll pull them closer to the nucleus, and they'll take up less space.
Yes.
And of course, smaller atoms tend to take up less space.
Less
too.
space.
So comparing hydrogen and beryllium, we
Again,
would think hydrogen is
Yes.
smaller
Smaller.
than beryllium because this has 4 protons and usually 5 neutrons.
5 neutrons.
And so that's a mass number of 9, and hydrogen has a mass
only
number of
1.
1. So we would think probably hydrogen is smaller.
Yeah.
Yeah, it may be, but we also know that the electrons take up space.
Mm-hmm.
And so if we compared the same energy level, let's compare lithium and beryllium and boron and carbon. They're all in the same
Yes.
row going across.
Yeah.
So then what we would expect is that as we go across the row, why did I write them going down? That's confusing.
Okay.
Beryllium, boron, then we had carbon. Scribble. That's
Yes.
professional, isn't it? Nitrogen, oxygen, and fluorine.
Fluorine, yes.
Okay, so as we go across this direction in the same row, then we're going from 3 to 4 to 5. So our
6.
nuclear charge is increasing,
Yes.
right? And what we would expect then is that they can pull the electrons in closer.
Closer.
And we would expect the radius, the atomic radius, to decrease. So we would think that fluorine is smallest,
Smallest among them.
and lithium is the
Is
biggest.
the biggest one.
And that is true,
Okay.
okay? Because lithium can only pull with, 3
3
protons, and fluorine has 9.
9.
Yeah, 9
Yes,
protons to
9.
pull with. So it pulls the electrons in a lot closer.
Yes.
It's hard to compare one on top of the other. Hydrogen is higher up and beryllium's farther down. Those are harder to compare.
Yes.
But going straight across, we always know that the ones with a higher nuclear charge are going to have a smaller radius.
Small radius.
Let's look at another factor to consider. Ionization energy is the energy to remove an electron.
An electron.
Okay, so what are the things that want to give electrons away? Like sodium has the 1 valence electron, right? And magnesium only has 2.
2.
But then when we get to something like oxygen, it has 6. 6 valence electrons. So which is more likely to remove an electron? The ones that don't have very many. It's easier to give away 1 than add 7,
Yes.
right?
And also 2, yeah.
Easy to give away 2.
2.
Hard to give away 6.
Yes.
It's more likely to take on 2.
It's easy to gain.
Easy to
Yeah.
gain, right. And so that's why we say cations will have
Low ionization
energies. It's easy to take their electrons away. Anions have high ionization energies. And this has to do with what we call metallic character. Metals donate electrons, and they form cations.
Cations.
So they have low ionization energies.
All right.
All right, well, let's compare this to the flame test
Okay.
results. Because remember how color and energy are related?
Related, yeah. They're related to each other.
Right, they're related by the frequency of light that we see.
Yeah.
And the lower frequency light has a higher energy. Purple was the highest,
Yeah.
right? And then red was the lowest.
Okay.
We just learned that in
In the flame test.
Yeah, the flame test. So lithium had red light. Sodium was
is yellow.
yellow. Potassium one is
Potassium is
purple.
purple.
So let's just compare our alkali metals real
Okay.
quick. Lithium has 3 protons. Sodium has 10.
has 10.
Okay, and then potassium would be 18.
Mm-hmm.
Okay. And so we would expect that to take the electrons away from lithium would be easier
Yes.
and most difficult to get them away from potassium,
Potassium.
because 18 can pull a lot harder than 3.
Yes.
Yeah.
Mhm.
And so that is a good demonstration of how this works, because red is the lowest energy, so it was easy
Easy.
to pull those electrons away,
Mhm.
and purple is our
Purple's
highest
high.
energy. What about yellow?
Yellow is
It's in
in the
between.
middle. Yeah.
Okay, well, here's a complicating factor. We would expect barium, with its 56 protons, to be the hardest one of all.
Yeah.
So it would be like ultraviolet or something, right?
Exactly.
A bigger
Mhm.
energy than
It has a
purple.
very high.
Okay, but if you remember what barium showed,
Green.
was green. This doesn't fit what we said.
Yeah.
Right, well, there's a complicating factor, because nuclear charge is not all there is to this story.
Yes.
Okay, so let's go back to Coulombs Law, and I'm going to write it down
To
again for
F.
us.
Okay. Q1, Q2.
So here's our charges, right?
Over, yep.
Over the
D squared.
square of the distance between them. So we've talked about the constant, that's not going to change, right? We've talked about the
The
charge,
charges.
so we know how to handle those.
And then
The
we
one
have
thing
the
we didn't talk
distance.
about,
Is the distance.
right, the distance.
Okay.
So if you get your charges farther apart, so here's our positive charge and our negative charge. We move this negative charge farther away from the nucleus, then what's that going to do to the force? Let's do some math. Let's
Okay.
call this 1. And then we'll call this, it looks like more than
More than 1.
So we'll call that like 3.
Yes.
Okay. So if I just have a 1 here, then it's going to be 1 over 1, so 1. And if I have a 3 down here, then it's
So that's
1
1
over
over 3.
3 squared.
Yeah. 1 over 9.
1 over 9 compared to 1 over 1.
1 over 1.
So which is greater force, the 1 or the 1/9?
It's 1.
Yeah, 1 is a lot greater
Yes.
force than 1/9. So distance from the nucleus weakens the attraction that's experienced by the valence electrons.
Okay.
Okay, if we get them farther away from the nucleus, we have less force.
Well, that's force.
And it should make sense if you understand charges like magnets. These two pull towards each other like magnets do.
Yeah.
And if you put two magnets close together, they pull harder
Pull harder.
than if you pull them far apart.
Exactly.
Right? So that's one factor. But that doesn't explain everything about shielding. You see, shielding is called shielding because other electrons get in the way of the valence
Of the
electron.
valence electrons.
So it shields,
Valence electrons
valence
from the
electrons
nuclear
from-
charge.
right. So let me get rid of some of this writing and I'll show you how that works. I don't want to get rid of all my writing, just some. I guess I have to scribble it all out. Okay, so let's pick an atom that's in energy level 4, or maybe 5.
Okay. What is that? What do you want, Miss Gray?
Let's do something not too bad. How about calcium?
Okay.
That's a good one. How many protons do we have?
20.
20. So we'd have 20 protons,
Mm-hmm.
and then 2 electrons in the first ring,
Yeah.
then 8 in the second, and then in the third row,
We have
8,
8.
and now in the fourth row we'd have 2.
Yes, and that's 20.
Okay, so that's how we show the Bohr diagram for calcium.
Okay.
And in its dot structure we would have 2 valence electrons, right?
Mm-hmm.
Well, these are the electrons that we're worried about. Only the outside electrons get to be involved in reactions.
Yes.
They're the ones that come in contact with other atoms. So these are the ones we're worried about. Look at all this mess in the way. We have a charge of 20,
20.
but we have 18 other electrons here that are blocking these 2 valence electrons.
Yes.
All right, so it's not enough just to compare the force here like we did.
Mm-hmm.
We also have to understand that these are getting in the way.
Getting in the way.
And because they're getting in the way, these 2 electrons will never experience the complete nuclear charge
Okay.
from the nucleus.
Yes.
So that's what shielding is.
Shielding is all about.
So we know as we get more we know that as we get more rings in the Bohr structure,
Mhm.
we get a higher principal energy level.
All right.
So what would happen to our effective shielding?
The shielding is increasing
Yeah.
or increase.
Right. So we get more charge
More
blockage.
charge block, yeah.
Right. So francium is the most reactive of the alkali metals, right?
Yes.
It's in row 7.
7.
Yeah. So where the principal energy level is 7, that means we have 7 rings of stuff
And there's
here.
a lot of stuff
Right.
blocking.
Yeah. Did I draw 7? I
Yeah.
sure did. And we have only 1 electron out here.
Yes.
He's going to leave at the first opportunity.
Mm-hmm.
So we're not allowed to do reactions with francium in a high
Francium.
school chemistry lab. It's so reactive
It's-
that it could
okay.
blow up.
Yes, the whole building.
More than
More
this
than the
building.
whole school
Yes,
building.
more like this whole site of Falcon.
Oh my gosh, that's
Yeah.
crazy.
So we
All
don't
right.
keep it here.
Okay. But do
Oh.
you have francium in here?
No way.
Okay.
Are you trying to get me in trouble?
No.
Let's look at electronegativity.
Okay.
In our slide before, we also called this electron affinity.
Affinity. Okay.
Okay, so we said that if you go across the period from left to right,
Left to right.
then electron affinity goes up because fluorine would like to add another electron, right?
Yes.
And so it's going to hold on to the ones it has and add another one too.
Yes.
Whereas lithium over here has only one, it's going to get rid of it
Get rid of it.
as soon as possible.
Yes.
Okay, so electron affinity going from left to right is going to increase. Now let's talk about shielding.
Okay.
Okay, as we go down the periodic table, in the alkali metals, let's see, move that out of the way. We talked about lithium and francium.
Francium.
Francium is has a very
yeah.
low, let me get my pen back. Okay, francium has a very low electron affinity. It gets rid of that electron quickly. Which one would be lower, lithium or francium, do you think?
We're talking about
Electronegativity,
electronegativity.
which is
Lower?
lower,
It's francium, right?
definitely, right?
Because, yeah.
Because there's more shielding here,
Mm-hmm.
so we block the nuclear charge that's there. High shielding means low electronegativity.
Yes.
Okay, so is it true then also for magnesium compared to calcium? The higher one
Yes.
has less shielding,
Yeah.
and the lower one has more shielding.
Exactly.
Red. Pink color. Okay, we're back in business. All right, so calcium has low
Electronegativity.
electronegativity compared to magnesium.
Magnesium.
Because calcium has 4 rings for shielding and magnesium has 3.
3.
Right. Let's look at nonmetals.
Okay.
Okay, because nonmetals tend to have high electronegativities. They become anions to form noble gas
Noble
configuration, right? So where oxygen has 2 rings and sulfur has 3 rings,
3 rings.
then oxygen has a higher electronegativity than sulfur because sulfur has more shielding,
More shielding.
right?
Yes.
More electrons in the way.
Mm-hmm.
Okay, let's look at another factor, atomic radius.
Atomic radius.
So we tried to compare beryllium and hydrogen, and that was hard to do because of shielding.
Yes.
We can certainly compare, though, beryllium to
And
magnesium. Yeah, beryllium is higher up in the periodic table,
Yes.
so it has a smaller radius, not only because it has fewer particles in it,
Particles in it.
but because it has only 2 rows of shielding and
Compared to
magnesium
magnesium has 3.
Right, so this outside, there's 2 electrons on the valence shell. They're held less tightly than the 2 electrons here, right? Because,
Yes.
I hate that thing, because we're blocking some of the charge here.
Yes.
Same happens over in nonmetals. As you go down, atomic radius goes up.
Goes up.
And then once you get down to the next level, it starts to, so what trend you'll see is that it goes across from left to right. You'll see it go down, 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 down.
Mm-hmm.
Then you jump to the next row and it spikes up again.
Oh,
And then it goes down, 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 down,
Down
and it goes
again.
up again and down, 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 up. So we get this zigzag line because as we go across, it gets smaller,
smaller and smaller.
but then you add another energy level and it has to go up again.
Yes.
Let's look at ionization energy. How do we remove an electron?
Mm-hmm.
So it's not just forming an ion, it's taking an electron away from the nucleus entirely.
Yes, and it needs energy to remove that.
Right. And it's going to take the most energy where the nuclear attraction is the strongest. So what we want is a high nuclear charge and low shielding to get high energy. Shielding. There. Spelling. Boy, what a challenge. That's what gives us the highest ionization energy. High nuclear charge and low shielding.
Okay.
Okay. So let's look for low shielding. That would be up top, right?
Yes.
Where we have very few. So here we have only one ring,
One
and then
ring,
two rings,
two,
three
three.
rings, and four, and so on. So what we're looking to see here is that as we go down from top to bottom, we're increasing the shielding. That means lowering the ionization energy. So it's easier to take an electron away from bromine than from fluorine.
From fluorine.
Right. Still not easy though compared to metals.
Mm-hmm.
Over here, the metals give their electrons away easily.
Yeah.
And we mentioned how francium has these seven
Seven
rings.
rings.
That's a lot. And so we have a lot of shielding going on. That electron just leaves,
Yeah.
right? So if you're comparing top to bottom, remember, on the top we have high ionization energy,
Mm-hmm.
and on the bottom we have low,
Low ionization energy.
Now if you're going side to side, then it's highest in the nonmetals and lowest in the
Lowest in
metals.
the metals.
Because the nuclear charge increases as Z increases, it gets higher ionization
Yes.
energy. So pay attention to see, are you in the same period of the periodic table? And if you're in the same principal energy level, then you don't have any shielding effects to take into
Yes.
consideration. Hate that thing. All right, so here's our summary of all the things we've talked
The
about.
periodic trends, right?
Right, the periodic trends. And it is all based on effective nuclear charge. And then, of course, the effects of shielding, nuclear charge
And shielding.
and shielding. I guess we didn't talk about which one of these wins in the end. If you have both of them happening at the same time, shielding makes
Wins.
more of an influence. Because remember that was the distance squared in the
Yes.
denominator?
Mm-hmm.
And since we're squaring it, then that increases a lot faster.
That makes sense.
Yeah. All right, that's it for this unit. We're done.
All right.
Time to take your test for Unit 4. You better study.
Yes.